Our group project is analyzing how bike sharers are affected by weather and time. And I'm Nicole.
And I'm Vera.
So for our final report, we focused on bike sharing programs, which have seen a significant increase in the number of bicycles used in cities worldwide. And bike sharing programs have been shown to reduce carbon footprint and gas house emissions in cities. And in addition, access to public bicycles can improve public health and can be used as a viable option for cheap public transportation. We discovered that bike sharing data is essential to understanding the behavior of bike sharers. And with it being a popular public bike sharing system, frequent maintenance of stations could greatly affect people who rely on bikes as public transportation. And this could affect the availability of bikes at a given time. So for our problem, we wanted to propose a solution for city maintainers who are unaware of the best times for certain stations to be under maintenance. We proposed several questions around our bike sharing data and how it can correlate, and we wanted to focus on this problem to be able to improve bike sharing programs.
So in this report, we wanted to test 3 possible hypotheses, where the first one, we believe that there was a strong correlation between the weather and the number of bike sharing users, since we believe that bike sharers would prefer to bike during warmer and clearer weather. And the second one is that we want to examine how adding weather features to our data set will affect our regression models and accuracy. And last, we also predicted that the multiple linear regression algorithm would perform the best in predicting the outcome of multiple bike features. And so our data sets, we got most of our bike trip and bike statistics from the Boston Bluebikes data set. And we also got our weather data set from the Wonderground site. And so for our independent variables, this was divided between the weather and the bike trip statistics. And so on the right side is mainly the weather data, and the left side is more related to the bike trip data relating to time and like average trip. And for our dependent variable, this was mainly the total count of bike sharing users between customers and subscribers altogether, given a date and hour. For our predictive model, we will predict the number of bike share users on a given day at a specific hour with all the aforementioned independent variables. And this problem is also a supervised learning, where our data set is labeled, and this problem is also a regression problem since our dependent variable is continuous. And of the machine learning algorithms that we will use the multiple linear, ridge, lasso, and SVM regression. And so for data wrangling, we applied a few algorithms over our data set, such as one-hot encoding to convert categorical data, such as the season feature, into integer data, as well as min-max scalar to pre-process and standardize our data set. And lastly, recursive feature elimination to select the top 3 important features, which are namely date, subscriber, and customer. And so into data exploration, we graphed a scatter plot between temperature and the user types of customer subscriber. And you can see that there's a strong correlation with higher temperatures relate to higher or more frequent bike trips. And in this graph, we did a line graph, which again is between customer and subscriber, but this time over date, where you can see as the date goes into the year, there are more bike trips throughout the year. And you can see that there's a huge dip between the months March and around May roughly. And that is highly likely due to the fact of when COVID-19 first came out. And so we also took that into account in our final report. And thirdly, this is a histogram over the number of bike trips by the hour of a day. And this distribution is not exactly a normal distribution since it's left skewed, meaning that there were fewer bike trips taken at the early hours of the day. And you can see that the peak time of the more frequent bike trips were taking place around the hours 15 and 19.
So after we visualized and analyzed our data, we wanted to train a ML model to track the performance of our data set. And we used 4 different models, all features with and without weather, as well as selected features with and without weather. And from our results, we determined that MLR, multiple linear regression, and ridge were the best performers, as they consistently scored with a 100% accuracy. Next, we wanted to test the performance on a testing data set, and we used this for ridge regression by using hyperparameter tuning for optimizing the model with different alpha values. And so from this result, we can see that the R-squared value is still very accurate and our regression model was not overfitted. For our hypothesis testing, we found that all three of our hypotheses were in fact correct. For the first one, bike sharers are more likely to bike during high temperatures, as we saw that there was a strong correlation with our biking sharers data sets as well as our weather. Then next, adding weather features did in fact affect the accuracy of some of our regression models, mainly SVM. And lastly, the MLR algorithm performed the best out of the four. For next steps, we encourage researchers to continue to analyze ride-sharing data to produce greater insights into bike sharers' behaviors. Future applications include using crime data or traffic insights to better inform bike sharers of potential dangers, or using predictive behavior to determine which stations would be most likely to be empty or full, or how certain demographics engage with bike sharing programs. So in an effort to further support the environment by reducing traffic congestion and pollution, applying this research knowledge would be super helpful to benefiting our communities. So thank you for listening to our presentation.